we have an exciting topic. We look into AVL
Let's go ahead
scenario
we'll go
simulator.
5 seconds, give ourselves a little.
And yeah, it's actually a free simulation platform this time. So it was just released 2 hours ago, so brand new. And yeah, looking at today's agenda, quick introduction to AVL. If you don't know us, then we will jump into our ADAS and AD solution. And we have the experts on the call. I will introduce them as well. Go into scenario simulator, a very quick overview, and then the majority of the 30 minutes we will spend on a live demonstration with live Q&A. That being said, you can post comments on LinkedIn and YouTube, and I will forward it to the presenters. And yeah, with that, AVL, 75 years of experience in the mobility industry, a lot of simulation work ongoing and a lot of R&D globally. And what we are looking today is basically the ADAS section of our simulation software ecosystem. And we have today on the call our ADAS expert, Josh Orlando. Josh, happy to have you here. And Josh is our main contact for ADAS on the simulation side here in the US. So he will hopefully be able to answer all the questions and lead through the demo.
Of course, excited to present this new tool released this morning. So hot off the press, looking forward to it.
Awesome. Yeah. And as mentioned, this was the event that happened today. It's one of the rare situations where we had a completely new tool released just 2 hours ago in this webinar. You can find the link here. And you will be able to rewatch this also at a later point if you missed it. We will still give you a very quick recap of what was presented and what is new and why is it exciting. And also you will be able to access the free version of this via this link. And with that, I also like to welcome to the call today a surprise guest. So we have Simon right after this webinar joining here us as well. There he is. Happy to have you here, Simon.
Hi, thanks for having me.
Yeah, with that, a very quick recap on how to get the free version. Basically, scan the QR code here or navigate to the link that is mentioned here as well. And we will send you an email with all the information you need to have to download the software and also to get the license. A very quick overview of what is included in the free version. Basically everything. It's fully functional. And the limitation of the free version is just how many simulations you can do per day and also the duration of the time. And of course, you will get paid access to the support team only in the paid version. But you can do everything with the free version, and I think that's exciting enough that you can try and set up really a lot of ADAS cases, as Josh will show today later. And with that, yeah, we jump into ADAS AD overview, and I hand it over to Josh to maybe show us the two tools in very brief description.
Yeah, so overall, the tool chain we'll discuss today is the ADAS AD AVL global tool chain, which is the scenario designer, which is a GUI-based interface scenario development tool, coupled with AVL scenario simulator, which is a lightweight, cost-optimized simulation package for ADAS AD solutions. With that, we'll hop into the AVL scenario simulator. So essentially, the AVL scenario simulator, if we describe it in one phrase, would be a high-performance closed-loop simulation environment tailored to controls testing and analysis. So it's modular. We have models included with the platform. It's open. It's OSI compliant in terms of ASM Open Scenario Interface. As well as ASM, it's built on the ASM Open Scenario standard and is compliant with ASM Open Scenario 1.x as well as ASM Open Drive. Additionally, We have full automation towards CI/CD pipelines, and we do the seamless integration with the Python API for your CI/CD tool chains. Based on this, we really want to emphasize with the tool that it is the right sizing of simulation toolchain to the development, calibration, or validation tasks that you are pushing forward. So on the left here, come directly with the tool is the object-based sensor models, which is essentially ideal models to do sensor simulation in range X, Y, or yes or no if there's a vehicle there or not, as well as statistical variation can be added to these sensors. But the benefit from the left side of the screen is the much faster than real-time capability. And then when it comes to the right side of the screen, where you're right sizing towards perception, sensor models, a little more deep into the sensor model architecture and simulation, that's more detail. So you're going to have less overall capability when it comes to simulation throughput, but it's really about right sizing that to the goal you're trying to accomplish in your simulation task. Additionally, the same thing comes when it comes to vehicle dynamics. So on the left side, we have included with the AVL scenario simulator packages is the simplified high performance 2D plus vehicle dynamics models. And that's going to be, you lose a little bit on correlation. You're looking at a max correlation of about 72%. However, you're still facing this, 1,000 times faster than real time. Can you execute these large amount of scenarios needed to validate or calibrate your system? And then additionally on the right, we do have an internal tool, but we do co-simulate with multiple tools. We showcase, in this case, VSM, which is high fidelity vehicle dynamics, in terms of how that's used with the tool. And you start to get more higher correlation around 97%. However, you're only running about 4 times faster than real time in this environment. But again, it's about right sizing your simulation to your task at hand. So I brought with me a couple of use cases today that were covered in Simon's webinar. The first one is the continuous testing, in which we are keeping the scenarios constant, but varying the software version. So software updates, sprint releases, as you progress through your software development, you can then utilize your test cases that you develop to rapidly evaluate your software variations. Additionally, the other use case that we'll talk about today is the virtual validation side of things, which previously covered is the high performance simulation straight out of the package when it comes to time, cost. You start to have very, very cheap, highly efficient scenarios executed in the platform. As you start to take this multi-pillar approach towards the different levels of fidelity in your simulation tool chain, you start to drop into the thousands, a higher detailed simulation. Maybe you have the vehicle dynamics model integrated, a high fidelity vehicle dynamics model, and then you move towards the real world testing in which you have high fidelity sensor models as well as vehicle dynamics model. You lose the efficiency and rapid execution of scenarios. However, that's just all about that right sizing, and it just kind of gives you the flexibility and modularity to choose the simulation tool chain development versus the task at hand. And now I will hop to my screen. Thomas, did you want to cover any of those things in rapid succession? I know I might have gone through that a little quickly.
While you're setting up the simulation, I will stop sharing my screen and hand it over to you. And I will just, in the meantime, before I do that, I will show once more where to find the scenario simulator. So you just go to the website AVL simulation tools. So simulation solutions offering all the way down here. And then basically here's use it for free, and you just need to fill that form, and yeah, we will send you all the information. And Josh, if you will start your screen sharing.
Yep.
That works. Perfect.
So here I have the simulation desktop open, and I will launch the tool from here.
And the icons at the bottom that you see on the left is Scenario Designer. In the middle, we have the brand new Scenario Simulator that was presented today. And on the right, we see the administrative part. So, for example, licensing and settings. And yeah, now it's open. We jump into the software.
Yep, and I will start to cover some of the examples included. We have ACC, ALKS, and LKA examples included in the simulation tool directly in the installation files. So I'm going to start with the ACC project. So as this opens, this tool Scenario Simulator is built on a decade or so of co-simulation tool development expertise. And
yes.
With that, as we
anybody who's really familiar, I think, with Model Connector Cruise M, we will see some familiarity in the GUI, but we will also show some new things. So yeah, Josh, can you maybe explain a little bit the model that we see here?
Yeah, so in the topology section here, we have ES Mini, which is our traffic simulation tool, the scenario replay tool, or the scenario execution tool. We have OC standard radar in the model here. This directly related to our front target object selection. Our software under test is going to be ACC in combination with this front target selection. This is a Python module, and this is a simple PID controller for ACC. And that should be pointed out because when you see some of the executions that I'll perform here, it is a PID-based function. It's not a full-fledged ACC function, so you may see some oscillations in the control algorithm. However, this is the use case of the tool being presented. Some other areas of the topology that you may find useful are this is our lightweight vehicle model, and then this could be replaced with VSM. ES Mini could be co-simulated with CarMaker, and so on. So if we go into some of the components that we do have that you can populate this model with, in terms of vehicle models, we have a large library, object sensor models. So these are OC standard sensor models that we have here. We have custom and standard interfaces for FMI integration, Python, ROS2, all available directly in the components tab. When it comes to custom signals and monitoring, and then finally we have tool interfaces to the nominal or the known tools in the automotive ADAS AD simulation kind of marketplace.
And
so if I
Simon just had a good comment. So the ACC that is here is basically a dummy. So what would happen is a customer would plug in their own ACC algorithm here. But yeah, you're basically ready to go and just need to plug in your own algorithm here.
Yep. So I will hop into the integration of test cases development there. So what I want to do here is just get rid of what I'll be repopulating in the tool. So essentially you go directly to your runs tab. From here, you can upload a scenario directly from any OpenScenario 1.x standard scenario file. From here,
just could you go back once to the parameters tab? Because even for me that was a little bit fast.
Oh, I was just deleting the one I'm going to replace. So this is an example model. I want to show the integration of the tool that will be repopulated, and we'll come back to this tab shortly. I just had to get rid of that so I could then import a new file with the same name. So okay, I will. So this is just based on my documents. It's a cutout open scenario file. From here, if I just press enter, we can see that not only do we understand the scenario by pointing out the actors and the parameters available in the scenario, but also as we import this, we will get a dialog box showing that the simulation understands and replaces the files necessary the parameters necessary, as well as identify those new parameters that have been updated or available in the scenario itself. So with that, once we've uploaded a single scenario, we can then go to this parameters tab and we can go to that scenario. So now we have a single case, and we can execute this in the live demonstration here. So you can just go in and press run, which is just running with your base parameters that you've had added.
Mm. And we see vehicle speed here. We see the distance to the
target. Yep.
Vehicle in front. Okay. Yeah. And
yep. And then you can also
decide distance.
Yep. Yep. And then you can also do a real-time simulation slowdown to then you can watch this in real time rather than the sped up version, which is, to execute, so many scenarios at a time.
Okay. Yeah, this is really nice for debugging. I think so when you start to plan out it would be way too fast to see what happens really.
Yep, and this is one-click toggle in this environment. However, you cannot change during the simulation execution or whether you want real-time slowdown or not activated. So now at this point, we'll go back to this parameters tab. And one thing I want to do to begin some parameter variation based on the cutout scenario that we've defined here is to add a couple unused parameters to this to further identify some additional variation in the simulation or in the scenario that we have integrated here. So what I'll do is I will just add a couple more things in terms of let's throw in there initial distance. We'll do desired distance. We'll also add desired speed and ego and knit speed. So now that we have this parameter set based on that logical scenario, and just a little sidebar, logical scenarios is the methodology. It's the open scenario, it's the open drive file, but it allows for parameterization. All the parameters that are defined give you the logical scenario. However, once you add values to these parameters, you then create a concrete scenario. So that's just a little bit background in terms of scenario definition that we wanted to cover in order for the people here to understand where we're going to. So what I'll do here is I'll change a couple of these parameters just to make things a little interesting.
So basically we start with a smaller distance on our ACC.
Yeah, we start with the smaller distance. We generate the cutout scenario. We change the lane change distance in which it operates the lane, and then we also change the point in time in which the sudden object changes lane to create that cutout scenario. So now if we're going to hop back right into these live runs. So what we'll do here is once we've set those parameters, we'll run again. And you'll directly see the difference in outcome when it comes to that new scenario generated. This abrupt change is that cutout scenario. So you see the front target object selection was giving us a little bit less than our desired distance. However, that front object moved over to the end of the other lane. So then we had an adjustment in our distance versus the closed loop control of the desired distance. So with this, I will move on to another great feature of this tool, which is here. So essentially, this is our run history and parallel processing environment. So this is the live demo. The live tab really only gives you the one simulation at a time execution. However, the run history, this also allows for a large set of runs to be executed directly on my computer here. And we'll kind of showcase this, 50,000 scenarios a day just based on my Dell Precision laptop versus, a remote workstation or the cloud environment as well. So we'll cover that very lightweight simulation tool chain and how that kind of benefits the developer at his desk. So what I can do here is just
this is really the new part, right? So this is the completely new part of scenario simulator where we saw, okay, we have so many lightweight simulations. We need a dashboard really to not lose the overview and have a good tracking of all the simulations.
Yeah, so we can take, and right now we have this cutout case, so we have one case selected, so we can run that. And we can kind of see how fast it executes a single case. And then from here, once the execution is completed, we can actually view the run directly in the scenario simulator tool. So now at this point,
you're running this right now at your office laptop, right?
Yep, right on my office laptop.
Yep.
So if we look at the case set, it took 17 seconds to run a single scenario. We have the progress success rate of the campaign, as well as we have the resultant KPIs of the cutout scenario that we ran. So we had no unique collisions. We had a max longitudinal acceleration of 8 meters per second squared and a max jerk of, let's say, 12.2 meters per second cubed. So the great thing is when it comes to the development of these different software functions, we can hop directly into this replay function and visualize what test case we had running. So here we have the cutout scenario, the vehicle accelerates to the additional vehicle and has that approach. And then, like we said before, the ACC function is purely a PID, so you're gonna see some weird behavior of an ACC. However, the functional scenario definition as well as the execution is what was needed and demonstrated here. So now, we talked all about how this lightweight tool applies the usage of many scenarios in a short amount of time. So in order to do that, we're going to hop into this parameters tab and we're going to start to parameterize and add variation to this case one that we've developed currently. So now that we have all of our different parameters defined, we then hop into the scenario definition or parameterization of the logical scenario that we've generated. So it's as simple as just taking, let's say we're going to check desired speed and ego init speed. So we want to change the ego vehicle speed throughout a large distribution of velocities and keep everything else the same. So something this simple, let's just start with 25, we'll go to 35, and we will set 5 levels. And then if we go to ego init speed, let's go to bound types as absolute. There's multiple different bound types that you can use. However, I'm just going to go with the first option for now for both of these parameters. And let's say again, 25 to 35 with 5 layers. So now we generate, and you'll see that experiment 1 is the same as case 1. However, we can just go up here to case 1. So let's select here, go to case 1, and we can delete case 1. Experiment 1 is the same exact scenario. So now I've generated a 25 scenario experiment of that individual logical scenario. So this is now 25 concrete scenarios of a cutout event for this ACC algorithm to validate this ACC algorithm. So now we can go back to this runs tab, and directly right away, we see this cutout scenario with 25 test cases. So let's run that. So here we're going to showcase a little more. My workstation here at the office, my laptop, we're going to run 24 of those 25 test cases all in parallel, just with a laptop, an engineering laptop in the office here.
And we see the blue box is basically it showcases that it's running.
Yep, blue boxes are running simulation test cases. Gray boxes are not run yet, and then you'll see the resultant pass-fail in the box scheme here. So now, as these start to populate, we see that we have a number of test cases passed, some that are failed, and these are based on the collisions, and we're still waiting for this last test to finish up. However, so right there, we have 25 test cases ran in 1 minute test duration for the campaign. So with that, we can start to dive into some of these test cases that we've developed. So we can come here. We've already seen this first cutout event. Let's hop into the second cutout event. We can look at, again, the KPIs directly in the GUI here, and then we can directly click on replay and then watch what actually happened in the scenario. And remember, we're only varying ego, desired, and init speed. So that's the only thing you'll see change throughout these scenarios. And then again, we can go back here and let's choose one that maybe failed. We have a unique collision here. So let's replay this one. And then what you can do here is you can stop the simulation and we can zoom in, pan around, find out what might have been happening in the scenario that caused the collision. And then we can also scroll back and forth to find out really what went down in the collision event that was in this test case.
So basically, now you would improve your algorithm, your ACC algorithm, and rerun it again, right? That's the
depends. Is the scenario that you've executed here inside the requirements that you generated for your ADAS control algorithm? That's something that you have to be aware of when it comes to not only the development of the system engineering, but however also the validation and calibration of the system as well. So all that is in terms of your parameters, how you set up the open scenario file, and then how you execute. So with that, we can go a little deeper when it comes to the number of scenarios that we run. So if we just run an additional case set that we have here, so let's take 300 test cases. So let's jump into a larger subset. And we'll kick this off and we'll kind of showcase the usability of the tool, the fast execution. And then from there, we'll again dive in and see what the performance of the ACC algorithm is in terms of the KPIs. And then from there, we'll show you where those KPIs come from. And then we'll open up to a Q&A. And I'll give Thomas also a little bit of Q&A for me if he has any questions that are coming to his mind after this short live demo.
Yeah, I think for sake of time, we need to already take any questions right now. So if there are any questions, don't wait. Just post them in LinkedIn, and I will forward it right now. Yeah, we have to unfortunately be cognizant of time, but I think you got a very good idea of how the tool looks, how it feels, how it works, and it's really easy to set up a lot of cases. And even with the free version, with 100 cases a day, you can already test a lot, I think. So we really encourage everybody to check out the tool scenario simulator by yourself. And we're happy to answer any questions. Reach out to us on LinkedIn, on YouTube, or via email directly. And we are happy to show you more, or hopefully you will download the tool.
And I will also ask that Simon, if you want to hop in now and give any information that you have regarding the webinar feedback, what questions you might have had this morning, and then again emphasize anything that you want in terms of the tool performance and usability.
Yeah, thanks for this cool demo. I think you really showed the important parts of the tool. Looking at the questions from the webinar in the morning, it was mainly about which interface options do we have to integrate the ADAS software. So what we saw today, this was a functional mockup unit, compiled Simulink model basically. The benefit when you compile it is that it runs faster and also it doesn't need the execution license. On the other hand, Josh just opened it. We also have support for ROS and ROS2. And also using the Python interface, there's basically all options for you to do any kind of wrapper. And it's being Python, so it's often you can do this in one afternoon, integrating any kind of service or interface to your ADAS software. We recommend, if it's C or C++ based stack, that you compile it and wrap it as an FMU, because this is really a solid standard that is industry-wide supported. And I think this was one of the biggest question. Another one we had was which versions of Open Scenario do we support? Here we support the version 1.0, 1.1, and 1.2. And currently we're working on 1.3. This was released a few weeks ago. So as you know, this always takes a bit then for the developers to implement. But that's basically it. One question was, what do I get when I buy the full version? I think that's actually a cool question because we're giving a lot with this free version. We are not limiting the tool. It's really the idea that you can see what is this tool about, how does it work, and does it add value to your tool chain? And the only point when you will need to upgrade is when you want to actively, productively use it and scale it up to hundreds or thousands of simulations per hour or per day. And another big point, what you get when you go premium is support access. So we have a worldwide team of support experts like Josh and Thomas here. And this is usually a lot of value too. You know, like these are still, even though it's a good usability, it's still an expert solution. This means if you get some support, you have someone to ask questions and guide you a bit. This really allows you to unlock the full potential of the tool. And yeah, I can still recommend you give it a try. It's really free. We are not terminating this. It's not a time box trial. It's really as long as you want, and you can really see how this works. One last question that we had was, how can I integrate this in a DevOps pipeline? Is there some command line interface? We have a Python interface, so everything you just saw in the user interface, you can also automate this with scripting using, again, simple Python. And this goes from model preparation, simulation control, so starting new simulations, but also monitoring them, and then also a unified access to the results. So we really got you covered here. And
awesome.
Feel free to reach out to us.
Yeah, thank you, Simon.
Yeah, thank you, Simon.
Is there anything coming through the chat, Thomas?
Yeah, thank you. So we got a nice thank you comment. So to you, Josh, for the presentation. So I will forward that. And with that, yeah, we are out of time, but still we can also answer questions later on in LinkedIn in the comments. And yeah, with that, I take it back.
Yeah, and if you want to show that free version slide one more time so they can scan the QR code if they want to as well, and also show this information.
Yeah. So there's further information, and there is also once more the information how to get to the website. We can also share these slides, so just reach out to us in the comments or via message, and we can provide the slide deck as well. And with that, we can really conclude this. Next week's Lunch and Learn is about NVH. So we are able to listen to NVH results, combining a simulator and AVL Excite. So that will be next Wednesday, again at lunchtime. And you can, as always, rewatch all of this also on YouTube and LinkedIn. With that, thank you, Josh and Simon. And yeah, everybody have a great rest of the week. Bye-bye.
Yep, thank you. Bye. Bye.
Okay, and we're out.